Hello everyone, I'm Frank and welcome to Learn How to Sudoku, where we take a very easy, very Sudoku puzzle and we break it down in detail so that you can learn how to Sudoku. Today's very easy puzzle is called Modulo Oblongata by Signe, I don't know how to pronounce it. Anyways, here are the rules. We have normal Sudoku rules apply, which means in every cell in the grid, place a single digit from 1 through 9 such that every row, column, and designated 9-cell region contains the digits 1 through 9 exactly once each. We have any group of 3 adjacent digits along a teal modular line must contain digits with distinct values modulo 3. Sets with the same values mod 3 are 147, which is 1 mod 3, 258, which is 2 mod 3, and 369, which is 0 mod 3. So for any 3 adjacent digits along this line, you have to have one that's from 1 mod 3, one from 2 mod 3, and one from 0 mod 3, which equate to the 147 set, the 258 set, and the 369 set. We also have digits separated by a black crop key dot are in a 2-to-1 ratio. So, for example, if this were, say, 2, this would have to be 1 or 4 to maintain the 1-to-2 ratio between them. And digits separated by a white dot are consecutive. So, for example, if this was a 6, this would have to be 5 or 7 to make sure that these digits are consecutive. And those are all the rules. If you like to play along, there's going to be a link in the description. And now, I'm going to get started. Let's learn how to Sudoku. Okay, so what I like doing for any type of modulo or any type of line where you have either they're alternating or they're in sets of 3, or they have to have essentially 3 unique digits, digits from 3 unique sets. I like to start coloring them and then basically take the coloring all the way around, because that will give you constraints about what you can have. So let's start here. We're going to make this pink, orange, and yellow here for these sets, because these have to be different sets, right? For every 3 adjacent digits on a teal modular line, you're going to have one from every set. So this is from set pink, set orange, set yellow. Well, what about these 3? These already contain one from set orange and set yellow, so this must be pink. And what you find is if you have the constraint where you have 3 adjacent digits must be from distinct sets, you know you can always have every 3rd digit is from the same set. So this must be pink to match this. This must be orange to match that. This must be yellow to match this. So then again, we can go along the line, pink, orange, yellow, pink, orange, yellow, and then we can, or we could do every 3rd digit here. So 1, 2, 1 pink, 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3 is all pink. Next ones are orange. Orange, 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 orange. Those are all orange, and then the last ones on the lines are all yellow. There's no way we can get that. So we just do the last ones. Last ones on the line are all yellow. And this tells us what is missing from all the rest of the rows and columns, right? So these are from the same modulo set, and they are in a 1-to-2 ratio. That almost certainly has to be 3 and 6. You have 4 and 8, which are different sets, 1 and 2, which are different sets, and 3 and 6. So this must be 3 and 6. 6 is only consecutive with digits that are in a 1-to-2 ratio. Sorry, 6 is only consecutive with 5 or 7, which are never in 1-to-2 ratios with another digit. So this has to be 3 here. This is 6, and this must be a 2, 4 to be in a 1-to-2, or to be consecutive with 3. That forces this to be 1 or 8. We know we're missing. We have 3 pink cells in column 6, and we have 3 yellow cells in this upper central box. So that means this cell cannot be pink and cannot be yellow, so it has to be orange. We have 3 oranges now in this box, so therefore this must be pink. How many in this upper right-hand box? We have 3 yellows and 3 oranges, so therefore this must be pink here. We have in row 2, 3 pinks, 3 yellows, so this must be orange. In row 3, we have 3 pinks, 3 oranges, so this must be yellow. In lower right-hand box, we have 3 yellows, 3 pinks, so this must be orange. In, let's see, lower central box, we have 3 orange and 3 pink, so this must be yellow. We have in column 6, 3 pink and 3 orange, so this is yellow. In row 8, we have 3 orange and 3 yellow, so this is pink. In row 7, we have 3 orange and 3 pink, so this is yellow. Let's see. In row 6, we have 3 yellows. Column 3. Column 3, we have 3 pinks, 3 oranges, so this is yellow. And I think these are kind of questionable. Orange and pink as a pair. This is orange and pink as a pair. Ah, okay. Yellow cannot be in row 6 and row 4, but we still have a yellow remaining in this right central box, so it has to be here. So that's yellow. And the rest are orange and pink pairs. But we don't know which is which. Okay. So this is orange or pink, and orange or pink. Okay. Yellow has to be, so this has to be 2 or 4 to be in a 1-to-2 ratio with 2 other digits. So that means if this is 2, this is a 1-4 pair. If this is 4, this is a 2-8 pair here. Okay. We have pink and orange here, so this cannot be 3 and 6. This has to be a 9 as the last 0 mod 3 in the row. This is again 1, 2, 4, and 8. This cannot be, though, this is pink, so it cannot be 1 or 8 to match this one. So this is 2 or the other. This is the pink 2 or 4, which is matching with, could be 2 or 4 here too. So that's fine. We have 3, 6, 9 here. This is 6 or 3, which would be consecutive with 3 is consecutive with 2 or 4. And 6 would be consecutive with 5 or 7. Yeah, that works. Remaining digits in column 8 are 1, 6, 1, 5, 6, 7, 8, 9. Obviously 6 and 9 cannot be in the non-yellows. So in the yellows are 6 and 9. And in the other ones are 1, 5, 7, 8. This is 3, 6, or 9 here, 3, 6, or 9 here, 3, 6, or 9 there. Hmm. We have 3 or 9 here, and this is 3 or 9 here, and this is 3 or 6. So this must be 3 or 6 here to match this. We just know one cannot be either of these. That's all we really know about that. Hmm. Um. Oh. If pinks were 1 mod 3, then this would have to be 1, 4 as a pair, and this would be 2. So this would be 7 if that's the case. If pinks were 2 mod 3s, then these would be 2, 8, and this would be 4. So this would have to be 5 in that case. So this cannot be 5 or 7. It's the pink 1, 8, right? Well, where is the pink 1, 8 in column 7? Can't be here because of the pink 1, 8's in the boxes, so it has to be here. So this is pink 1, 8, which means this cannot be 1 or 8. It's 2 or 4. Okay, so this is a 2, 4 pair, which eliminates 2 and 4 in the rest of the box. So this can't be 2 or 4. It's 5 or 7, which is only consecutive with 6. So this is 6 here. This is 3. That's 9. This is 6, which makes this 3. So this cannot be 3 here. This is 6 or 9. This 6 eliminates 6 here, so this is 9, which makes this 3. What does that mean? I'm not sure. 6 and 9 are only consecutive with 5, 7, or 8. Okay. This is 2, 4, 5, 7, or 8, which is pretty broad. Where is the orange 2, 4 in this upper right-hand box? Cannot be here, can't be here, it must be here. So therefore the orange 2, 4 in row 1 has to be one of these, has to be that cell, because it can't be here and it can't be here. Orange 2, 4 cannot be here. That means in this left central box, orange 2, 4 has to be one of these two. That doesn't tell us too much. Where's orange 2, 4 in column 9? It has to be here. Where's orange 2, 4 in this lower left-hand box? Can't be here. It's one of these two cells. So it cannot be here in this middle central box. So this must be orange 2, 4. Okay, and orange 2, 4 cannot be here. Cannot be here as one of these two, so it can't be here. So this must be orange 2, 4 there. Okay. Orange 2, 4 is one of those two. Orange 2, 4 is here, 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 here. Do we have anything about pink 2, 4? Cannot be either of these, so this must be pink 2, 4 here. Where's pink 2, 4 in column 7? Can't be here because of the pink 2, 4s in the boxes, so it must be here. Pink 2, 4 cannot be here and cannot be here in this lower central box, so it has to be here. So this is 2, 4, which forces this to be 3 next to it. So that's 3, which means this can't be 3 here. Pink 2, 4 cannot be here, cannot be here. So in the central box, it has to be here. Can't be here, here, or here. So pink 2, 4 is here. Cannot be here or here, so pink 2, 4 is here. So we have all the pink 2, 4s, I believe. We don't have all the orange 2, 4s. Okay. So this has to be 6 or 9. This is 6 or 9. This can't be 3 or 9, so this must be 6, which forces this to be 9 here. This is a 3-9 pair because we have a 6 in the box, so this cannot be 9 here. This is 6, which forces this to be 9, which forces this to be 9. That makes this 6. And since this is 9, it's only consecutive with 8. Okay, so we know... So oranges have to be 8. So they're 2 mod 3s. So the orange 2, 4. We know what the pink... So the orange 2, 4 is 2. The pink 2, 4 is 4. So pink 2, 4 must be 4. And orange 2, 4 must be 2. Because this is 8. So this cannot be 1 or 7. It's 2 mod 3, so this is 5. This is 2 or 8. That's fine. 2 is in 1-2 ratio with 1. That 4 forces this to be 8. So this is 1, 2, 4. That makes this 7. So this has to be 1 here. This can't be 1, 5, or 7. So it's 8, which makes this 5. This is a 1 mod 3, so it must be 7. That leaves this as 1. That leaves that as 1, which makes this a 7 here. 1 and 4 force this to be 7. This 4 and 7 eliminate 4 and 7 here, so it's 1, which makes this 7. This cannot be 1 or 4, so it's 7, which makes this 1, which makes this 7. That leaves that as a 1. Where is 7 in this right central box? It cannot be here, so this is not red, or so not pink, this is orange, which means it can't be orange. This is pink and is a 7. That leaves this as a 5. We have all 3 oranges here, so this cannot be orange. This is pink, which means this can't be pink. That's orange, so we have 3 oranges in row 5, so this can't be orange. That's pink, which means this can't be pink here. So that's orange. So, this has to be 5 because we have a 2 and 8 already there. 2 and 5 force this to be 8 here, which forces this to be 5 there. That moves this as an 8, which makes this a 5, which makes this an 8, which makes this a 2. So then this is 5. To satisfy that, this can't be 2 or 5. It's 8, which forces this to be 5. This can't be 2 or 5, so it's 8, which makes this 2, which makes that 8, which makes that 5. We have 7 remaining here. We have 1 remaining in this box. And we've done all the pinks, I believe. So now we have 3, 6, 9. This cannot be 9 here, so this must be 3. That makes this 9, which makes that 3. That's 3 in the corner. We celebrate because we're nowhere close to solving this. This is a 6, 9 pair. This can't be 6 because 6 in the column, so that's 9 and 6, which leaves this is 3, this is 9, this has 6, that 3, and that 6. And that's how you solve it. Yeah, it's a little bit more difficult than very easy, I would consider. I mean, if you know if you have knowledge about how these sets work and you like coloring, then this flows very well, right? It's just I don't know how many people know of these things, but yeah, pretty cool. Pretty cool. Yeah, overall, it's fairly close to very easy, so I guess I could see that being rated that. Nice little puzzle here. Anyways, I hope you enjoyed this episode of Learn How to Sudoku, and I'll see you next time on Frank Puzzles. Take care.